Okay, welcome to the CARC Emerging Centers call number 49, October 23rd, 2024. This is part of the cybersecurity focused month for all the People Network tracks. And this month we've got Erik Deumens from University of Florida and Alex Feltus from Clemson to talk about their experiences with cybersecurity. For those who are just joining us maybe for the first time, CARC is the Campus Research Computing Consortium. It consists of the People Network working groups, interest groups, operations group, and RCD Nexus. The People Network is an ongoing conference that lasts all year round that has different tracks. You can see the tracks in the slide, and you're currently in the Emerging Centers track, which is how do sort of small centers, sometimes one person's initiatives kind of get off the ground, share tactics and practices, and get better at what they do. Within CARC, the working and interest groups also address specific topics, and the operation groups sort of keep us all moving forward and operating as best we can. So welcome. Please sign into the call doc, which will get shared in chat here in a second. And with that, I'm going to give the floor to Erik.
All right. Well, actually, I didn't prepare any complicated slides, but I'm going to show the main resource that is available to everybody, and then I'll talk about regulated research community of practice. So what has happened in the last decade in academic research environments is that there is a steadily increasing requirement to meet all kinds of requirements. And people just keep coming up with new ideas to try and protect our research. Now, there's good reason for doing this, but it's still a major pain. And it's sort of a reaction to what's happening out in the world. I think if you read the news, focusing on what's happening in cyber infrastructure and cybersecurity in particular, then I think everybody sort of knows that we're in some kind of a cyber war. There's a large number of bad guys who are using cyber infrastructure to do all kinds of nefarious things that make them money, which is the prime motivator. And then they also like to cause havoc if they can. And part of that is also affecting the research community. Initially, of course, they're trying to do all kinds of spam, social engineering, all kinds of things that we are familiar with. But in addition, there are all kinds of research ideas that get in places where they shouldn't be. Now, normally, we expect this in the context if you are doing research for the Department of Defense and there's something that has to do with national security, then we all sort of accept, yeah, you want to pay some extra attention to keeping the data that's involved in your research and the research results and all the intermediate results. You want to keep them safe. That is understood, and I think that was sort of the prime reason for regulated research around like 14 years ago, 2010. And there was one exception, which was if you did research on protected health information, because the HIPAA, the Health Insurance Portability and Accountability Act of 1997, it required that you would take special precautions when you do research on healthcare of human patients as protected health information, and you had to do something special. So if you were working with a hospital and with data of that, you knew how to deal with it. But all other research was essentially open and nobody worried. But then increasingly people discovered that there is something going on with research that affects even fundamental research. And that is when you were doing research, when I was a graduate student, all the preliminary results essentially were in physical notebooks in the labs where I was working. And if we had conversations, we had conversations. We may have had some letters that we exchanged with collaborators. We may have had some phone calls, but it wasn't easy for people who wanted to steal my research to get to that research. They had to do some complicated things and it wasn't worth it. With everything now being digital, you have all these computer systems, all my stuff and all the stuff of researchers who do work today is on some system. And all these systems are connected to the internet. And so the bad guys, if they find the proper way, they can get to it, steal your preliminary results, and publish them, ask for patents before you can publish it and claim your right. And so actually that has caused people's careers to be jeopardized because they were now no longer the first person known to have done something. Somebody else stole it from them and took it. And so there's now this general precaution atmosphere to protect even fundamental research. And in 2010, that was formalized by an executive order for the federal government to define a unified approach to get controlled unclassified information and come up with some ways to protect that. And they started working on this in 2010. And in 2015, the first official publication about that came out with a new draft for the federal acquisition rule. So this is something that most people who have worked with grants may know, but some of them may not know. And that is that if you get a grant from a federal agency, then eventually there's a contract between the federal government and your institution. And these contracts are governed by what is called the FAR, the Federal Acquisition Rules. And they put in there that if you are dealing with controlled unclassified information, and there is a website, the National Archives website, they are responsible for defining what is controlled unclassified information. You have to deal with certain controls to protect that data. And these controls are documented in a document that is published by NIST, the National Institute for Science and Technologies, in NIST 800-171. That's their specification. So in 2015, they made a new draft, and it caused a lot of response from the whole community. It's like, no, hey, this imposing that security measure is very complicated and onerous. We can't just do this overnight, which is what this process was going to do. But the Department of Defense jumped on it, and they said, we want to do this immediately. Even they got fierce pushback, and they relented, and they said, okay, we'll have to have this in place by December of 2017. And so that was the first really big change in how you had to deal with securing data if you wanted to deal with the Department of Defense in particular. And that just from 2017, it got more and more complicated. The Department of Defense then discovered by a study they did around 2019, 2020, that this new rule was actually not very well implemented across the people that were of interest to the Department of Defense, the people they do contracts with, which is called the Defense Industrial Base, DIB. And so they came up with a new program that instead of just saying, hey, this is the rule, you sign this contract, you have to self-attest that you are putting these controls in place. We are now going to establish a new mechanism whereby there will be an explicit certification process. And that created the program called CMMC, Cybersecurity Maturity Model Certification. And that made things a lot more onerous. And now a lot more institutions were paying attention, because it's one thing to sort of say, yeah, we check these controls and we have them in place, and then trust that that's good enough. And then some auditor coming and checking on you and say, no, we want to do, you're not doing the right thing. You think this is good. And this is no surprise, because auditors are professionals of their own right. And to just ask an IT professional to create a system that meets auditing standards and read this sort of legalese document that is NIST 800-171 and interpret it correctly is not a trivial matter. I mean, it's not what people have learned as part of their job, and it's not something they do, and it's easy to make mistakes. So that is where Carolyn Ellis and myself and several other people wrote a proposal to NSF to create a community of practice where people who are tasked by their institutions to deal with creating an infrastructure and maintaining an infrastructure and making sure that it meets these compliance requirements, and so that in that community we can sort of learn from each other and not having, just being all by yourself and having to reinvent the wheel over and over again. And so that created the regulated community of practice. We started in December of 22, and we got a 3-year award. And now at the end of 24, actually, it was December of 21. And now in the December of 24, that grant is ended. And it turns out that this community of practice and the work that we did hit a sore spot, I guess, and everybody is just totally excited about it. And we had an enormous success in gaining people. As you can see on this diagram, this is a map of all the institutions that are actively participating in our monthly webinar calls and in the Slack channel where we can talk to each other. We basically have different members from the community share their experience with others. We have on this website massive, there's a list up in the corner that says resources. There's a lot of webinars that have been recorded. There are documents we created. There are guidance documents. There are training materials, all kinds of materials. So if you are tasked as the one and single person at your institution to sort of create a compliance program and meet these requirements, then these are your friends. You can go here and learn from them, and they will happily talk to you, set up a conversation one-on-one, set up a conversation in a group. Sometimes people raise questions, and then we invite somebody to give a webinar. And this success has then led to NSF noticing, and NSF has now incorporated this regulated research community of practice as part of the renewal of the Trusted CI Center of Excellence. And this was announced just in the beginning of this month, like not last week, but the week before that. That's when we made it public that this grant has been renewed for another 5 years. And RCOP is now an integral part of Trusted CI. And so this is a place where people can go. And like I said in my introductory story, the Department of Defense is the beginning, but then in the last couple of years, it's gotten a lot more serious that really this is not something you can ignore. Initially, you could think, well, Department of Defense is Department of Defense. Not every institution, not every researcher is interested in doing work with the Department of Defense. But NSPM 33 came out, which is the National Security Presidential Memo, and it basically says something to the effect, if you are an institution that gets more than $50 million of grants, you have to make sure that all the research data that you're dealing with meets certain security standards. They haven't said in that memo that came out, I think, in the beginning of 21 or around that time. They haven't said in that memo specifically what controls there will be, but there will be specific controls specified by the end of 25. And recently, a follow-on clarification memo was published that gave some guidance as to what to look for. And that guidance was informed by a query by NSF, a request for information, and they talked to EDUCAUSE and people like ourselves, and we gave them input on what our concerns were on how to implement this. Because as you can imagine, if they would impose the requirement that all research data that is flowing through an academic institution, small or large, needs to meet NIST 800-171 level of controls. That's not a trivial matter. NIST 800-171 has 110 controls, and these controls translate to what is known as assessment objectives. So if an auditor comes and tests whether you meet these controls, they are going to ask to show that you show some evidence that you are doing what the controls are saying. And that could be like, if a user is now fired from the institution, do you have a process to, in a short time, verify that that person is no longer working for the university and that their account is now disabled so that they no longer have access? That would be one assessment objective. And the total number of assessment objectives is 320. These 110 controls have 320 objectives. And so that is not a trivial matter that you can just impose on any information. So this is a serious thing, and that's why the regulated research community of practice is so valuable, to show you what can be done. The second aspect and value of the regulated research community of practice, RCOP, is that we as a group can go and have a conversation. We have been having conversations with the Department of Defense. We've been working with NIST. We've been working with EDUCAUSE and CASC as a partner to talk to federal agencies about details of how to manage this thing. In this summer, I think it was in July, NSF published a Dear Colleague letter where they said, we will treat in the future proposals as controlled unclassified information, and they have to be managed according to NIST 800-171. And that Dear Colleague letter was so short and lacked so many details, opened so many questions. They published this letter on Friday. We, Carolyn and myself, contacted them immediately, and many others across the country sent emails to their program officers and NSF, so that over the weekend, NSF was inundated with concerns about, hey, there are all kinds of questions that you're not answering in this letter. On Monday, they retracted the letter. And then, because they knew about RCOP and they knew that we represent a large number of institutions, NSF reached out to Carolyn and myself, and they said, hey, can we talk to you and get from you the input from your community about what the concerns are? So on our Slack channel over the week, we basically asked everybody, what are your concerns? We collected them, and then we had a conversation with NSF. And so now we have developed a frequently asked questions document for NSF. And then in the near future, NSF will publish that DCL again, but this time the answers will be there and they worked with the community. So that's one of the things that the RCOP brings as a value. And this is where I'm going to stop. If there are any questions, please shoot.
All right. Thanks very much, Erik. Really appreciate that overview. At this point, I'm going to hand it over to Alex.
Can you see my screen okay?
Yes.
Oh,
yeah. But you are muted.
Hey, sorry about that. Hey, so I'm Alex Feltus. I'm at Clemson University. I'm a genetics in the genetics biochemistry department. I do a lot of work in agricultural genomics and human genomics, a lot of biomedical work. So I have to deal with protected data. When I was doing plant work, nobody cared, right? Nobody cares if you release a DNA sequence for a plant. And so I'm here as a researcher perspective to tell you my experiences in the war, the cyber war that Erik was talking about, as a end user here. And also I worked with IT departments. I was the PI for CART for a while, get the IT world. So I'm trying to be an interface between the two things. This is my research slide. So there is criticism of researchers going on and on and on about their research, which I get. This is my slide. This orients you. We're doing some modern stuff. We're using diffusion models to be able to transition between gene expression states. So we take numbers that represent gene expression and then do things like simulations through GANs and diffusion models and other means to be able to understand what features are changing in the process of going from tumor to normal. And this works for any biological system. So we're doing a lot of work in different systems. But to be able to do this kind of work, of course, like this is a little sliver from a grant proposal I just submitted NIH, my first R01 proposal. That I estimated in the proposal for this is the NIH, right? I'm an NSF guy, and so you usually get like this kind of stuff in NSF projects, but maybe not so much NIH. That I have to run 225,000 GPU jobs, right? They work on the A100. If I might get access to H100s in our cluster. I've got a lot of compute to do, a lot of AI compute to be able to do this, to the point where I wrote this as a specific part of my proposal. The reason why I bring this up is that all the data analysis I do is large data sets, and so we're really working pretty much really at the upper tera, lower petascale for a lot of the work that we do. So you can imagine, like, I don't have scratch space to do a lot of my work, so I need massive storage, massive compute. I need give me the fastest GPU and I'll burn it up pretty quick. I need to do all this in the context of a protected HPC environment. Thankfully, at Clemson, our cluster was used for Medicaid transactions. So there's already like a lot of security baked in, from even before the cluster was there in our data center. So I've been able to work with our IT department, our research computing data department, and really be able to facilitate my work. So anyways, I need lots of compute, and I need all the legal things, right, around what I needed. I'm a open scientist. I always try to publish open source. I'm trying to democratize everything. Where I'd love to be able to take cancer data in my classroom. I teach bioinformatics class, and we use the cluster to do the work. I would love to be able to give them human data, like have security protocols in there, or simulated human data, so they can be studying cancer while they're learning their basic biology stuff too, right? I'd like to be able to do all that. So I'm always trying to, they're immiscible boundaries, right? They're not immiscible. There's like a barrier between them. Maybe there's one pore of like trying to do open science versus protected science. It's insane. But this is just, I wrote down 14 steps that I went through to be able to do NIH data cancer data sets that were designed for general research use, right? There's a data use agreement, and I had to get IRB approval and everything. But I'm much better now because I went through some of these processes. But again, I'm a researcher, I'm a biologist. This is what I had to do, this is what I had to deal with. You have to do the science, you have to design the experiment, find the appropriate data sets. It takes a lot of work. Find a student that's interested and capable of doing this work. It takes a long time to do this, but this was the hard part for me, or some of the hard parts is I needed to be able to have the hardware. I had the hardware actually to be able to do the work at Clemson. That's no problem. This new problem that I'm doing, I need some new hardware. I need to buy some GPUs. It's going to take me, at least 2 grants, with a super success rate of 50% if one of them gets funded and one of them doesn't, to get the hardware before I can do the work. Thankfully, again, at Clemson, I can do the work while I'm trying to get some of the hardware. This is to be able to do the work. You have to get institutional review board approval, IRB, to protect people from nefarious medical studies and things like that. And so to do that, I have to go and work with our IRB department. And this is probably true for a lot of small schools if you're on here. Like IRB people are very heavy on doing like putting frogs in blenders and doing wet bench work and not this computational work. And so I'm trying to come at them with like, here's a petascale experiment to people that don't, typically they use their laptop for, doing Excel based big data processing on Excel spreadsheets, right? So like the communication thing is very, very challenging to get sometimes the IRB people involved. So I have to get this, the CISO involved, the HPC admin, the storage people, everybody. And like, I know what I'm doing. So it's very difficult to do all this. Anyway, so then once I got, I can actually do the experiment. This is a long time. The approvals that I needed to be able to do the data use agreements, I'm a state school, South Carolina State institution, and there were some clauses in the NIH, data use agreements that there was one word actually, a very long 4-letter word that starts with I, that when I was unable to get the lawyers to change it, took me, I think it was 4 years to go from trying to get the data to be able to get the ability to sign a DUA. Once I did that, then I was able to get the data right. So really, there was a lag here for me of many, many years. So I can't give up. I guess I don't give up. So I was able to keep the momentum for 4 years, but that's not always the case, right? Once you have the everything's facilitated, you have to access the system, right? And this is all covered in the IRB agreements with biologists and IT people and security people and that kind of stuff. And this is just sort of the process of getting data from the NIH. There's they give you encryption keys, they give you or tokens to be able to go and pull down data using some things like Aspera, NIH SRA toolkit, some Aspera products and things like that, whatever those are called now. Anyway, to get all the data on there. And so then once I get the data on there, right, I have to keep it in storage in scratch space that's secure. And so there's very finite resources for this, right? So we have to be able to take our petascale experiment and take it into the gigascale or the low terascale to be able to really the low terascale now, the kind of stuff that I need to be able to do. So if you don't have access to 10 terabytes of a place to put intermediate files, let alone store the results, it's in a secure environment, and the GPUs to run it, and the IRB approval, and the lawyers, and all this stuff, it's just, I mean, I can't imagine how many people gave up along the process with this. And I say this because this is how you cure cancer. This is how you get sick kids out of bed, is doing this kind of work. And there's a lot of pressure to not do it. So I'm here to answer any questions from a professor perspective.
I've got a question, Alex, from the faculty perspective. One of the things that's sort of come up in the conversations I've had is that people are like, what, just tell me what I need to do to get the research done, and sort of make it simple for me to get started. How do you think some of the communication and discussion of these requirements could be improved if we wanted people to be sort of aware and I think they're willing to take the steps. It's just like you said, you want things to move at the speed of research still and be safe.
So my experience with, so I try to make myself a campus champion for this. Like I share my IRB and try to be very proactive with helping people, and I do that. But the people that I've worked with a little bit, typically what happens from other, and this is me, my weirdness and my institution, everything, that I'll go and say, hey, look, here's my IRB. How much storage do you need? With all the constraints you need to be able to actually do the experiment. You can't do the experiment if you need an H100 and you have a laptop, it's not going to work, right? You got to have these equipment. So I'll do that, and then typically what happens is I won't hear back from the faculty for a long time. I'll check in every once or check in once usually, and then I'll find out that they're talking to lawyers about getting approval for the word that I got approval for in my IRB. So typically people go and immediately reinvent the wheel, and because I think part of it's that, to be honest, is that it's difficult to communicate to people that don't know what a CPU and a GPU is in a secure environment, and SSH and these things, like they don't have any idea what you're talking about. So I think it's just difficult to have that communication.
So similarly to that, since you just said the word secure environment, what is the minimum viable product on a secure environment? Can I use the same storage arrays that we use for other things as long as it's access controlled? Do I need completely separate compute capacity? Can I just reinstall the node and maybe, make sure that nothing but sensitive stuff is running there for the duration of that reboot?
Well, I can give you a little answer to that. It's a little bit more complicated. So for dbGaP, the new data use agreement that NIH just published requires that you meet all 110 NIST 800 171 controls. And there are many ways to do this. So some of the things you suggest are technical approaches that may or may not meet the requirement and pass an audit. And so that is, that's where things like RCOP are useful, because that's where we discuss exactly those kind of questions. It's not easy to just say, these are the things you got to do. Actually, the original DB gap that was in force before this one has been published had explicitly maybe less than 10 things. You have to do these things. And the most important one was you have to make sure that those users who have access to the data know that they can't share it with anybody else who doesn't have the license. And the way you do that is by making sure that the data is put in a folder that has the proper access controls put on it. So that's something that the system administrators could easily take, implement, and be done with it, and make sure that it didn't get changed, and that you could check it on whatever, some regular basis, that nobody modified those permissions, and that was it. Making sure that you have a 171 controlled environment is much more complicated, and it's not even that you have to do 110 things. Like I said, you have to be able to produce 320 assessment objectives to make sure that you meet it. And the way the NIH requirement now specifies you have to do it is the vice president for research who signs the DB gap user license. Actually, that's the way it happens at the University of Florida. Faculty or anybody else is not allowed to sign it because they cannot take responsibility that the system will meet those controls. So the vice president for research signs it, and he or she needs to make sure that the person who operates whatever environment makes those controls. That could be the CIO or the research computing director or whoever is in charge of that environment, that they are sure that these controls are met. And the best way to do it is to actually hire some auditor to come and assess your environment. Because if you, as a bunch of IT people, read these controls, you very often misinterpret them. And actually, there are some institutions who have done that, and they're now in the scope of the Department of Justice with some lawsuit. So it's not nothing. You have to be careful.
So are these all still fundamentally outcome based though? So like it's probably been 10, 15 years since I had an ITAR project.
Uh-huh.
And at one time, the ITAR rules, and I know it doesn't cover everything, was ensure that, foreign nationals don't get access to the data. And so we did that with a combination of physical controls to a room, ACLs on a file server, network controls to where only these machines can access the data. Only these users on these machines can access the data. And it had to be like we did basically an overlapping set of that. Now, we never really got audited or inspected by outside on that. So that was readable to me.
Yeah, and
so
that's
from
the way.
What you're saying, and I also assume that we don't necessarily, if we can demonstrate that we meet things, that it's not necessarily a hard requirement to have the completely isolated environments, but it just might be easier or.
Yeah, it's not a requirement that it completely isolated. There are ways to get around, but it's not just these simple controls that we had in the past. They are still there, or in some form, but there's a lot more you have to do, which has to do with policies and procedures and training mechanisms and monitoring and logging. All that thing is now included, and you need to show that you are doing this in a diligent way.
I'd like to add a little to this conversation. So this, can you see my screen?
Yeah.
Yep.
You can see Drake and Vivian. So these are two kids that have hundreds of they're kids that are born with NKH. They have hundreds of seizures a day, and typically they don't last a week. Drake and Vivian are about 7 to 6 years old, I believe. They've been around for a long time because their mom figured out that if you give them boiled cinnamon extract, it stops the seizures enough for them to to survive. But so, and in the context of all these laws and all this, the stuff that's being put out there to protect medical data, and I totally understand it and agree with it. It's awesome. But balancing that with these kids need to understand how Cinnamon's working, one of the projects that we're working on to try to help them not die. And so I understand that we have to deal with all these security issues, but we have to balance the ability to do this. Like if I was told I can't do my research because of these 150 theses put on the door of the healthcare industry, like I can't help these kids. And so I just want to pull the heartstrings if anybody wants to pull.
No, and actually that is important, what Alex is pointing out. And that is why often when an administrator at a university receives this mandate from the federal government, they say, oh, this is about data. Let's give it to the IT people, or let's give it to the CISO, the information security officer. But that person by definition, has as his focus to keep things secure, right? So if you allow them to architect a system, and I've been there because I've had the system that I inherited that was built by a CISO, and it was secure. I mean, they had to build it in 90 days. They built it in 90 days. We put the data in there. It was secure. But the researchers couldn't work on their data for 6 months until we had properly modified it so that it was actually usable. So although the CISOs should be a partner in maintaining and managing or design or sort of reviewing that system, you should not let them design it, because they will not design it in a way that serves the mission, which is what Alex is trying. I mean, if you kill the mission, then the whole thing is meaningless, right? So you have to make sure you have an environment that serves the mission and is also secure. And it can be done, but you cannot ask an IT person or a CISO person to design it, because then, and that's again what RCOP is good for. We have these people with different environments, different experiences. There are some institutions where the CISO did it, and there are some institutions where other people did it, and that's where we can exchange and come to a compromise, and together as a community move forward to still do effective research and at the same time make sure that the data is secure.
I've got another question I wanted to surface for sort of generally from folks. We're recently have been going through our data use agreements in order to identify things that are potentially impacted by this new NIH ruling, of using the restricted data sets, and when we've gone back to our research administration folks, we're like, well, how do we find the people that have awards that allow them access to these? And it's been a bit of a scramble. It has not been easy to find these folks necessarily. The DUAs seem to be the main key to be able to lift on. Do folks have any experience with identifying the faculty that are in these agreements and have?
Yeah, so this is where I can tell you the story of the University of Florida. Our vice president for research was in some ways a visionary, and so 7 or 8 years ago, he came up with a new policy that no faculty member or no department chair or no dean is allowed to sign any data use agreement. It has to be done by the Office of Research. And they created an efficient system to get it done, but that means that they now have a list of all the data use agreements because they're the only ones who are allowed to sign it.
That does create a single point where everything has to come through.
Yeah. And so now when NIH comes up, I'm working with them because the first thing they did is they wanted to ask me as the director of research computing, hey, we have this environment that is NIST 800-171 compliant. Is that the only environment we have where we can certify that that's the case? And I said, yep, for now that's the case. Let's see how we can negotiate and maybe do something more flexible with NIH, whatever. So I'm working with them. How can we make this productive? We have this environment that works, but the environment is a little bit more onerous than what they've been using in the past. And so, we want to make sure that we don't impede research and that people, like Alex was saying, will say, well, if I have to do all these things, I can't do it. And I'm just not even going to ask for the data use agreement. I'll just do something else.
Because collaboration is one mechanism with that too, is just to work with some other institution. And I look at it from a retention perspective, you're only one step away from like faculty moving to the other institution if you can't deal with this kind of stuff. But I do think like at Clemson, like once we got through this first one, I know that some of the other people have tried to use the same data sets, that it was an easier process for them, because having that first conversation is very, very challenging, right? And impossible for me as a faculty I get lots of pieces of lots of things, but it's coming through me. I am the one that's doing the research. And so everybody is supporting me, and to being able to communicate with lawyers and CISOs and network engineers and whatever, it can be very
and that's another thing. This is something that you have to communicate, and that my boss, the CIO, and I have been communicating with our administrations. Like, do you want our faculty, whom we hire for teaching and research, to spend a significant fraction of their time learning about all these audit things and talking to lawyers, or are we going to hire some people to manage this in a way that is open, and they talk to the faculty to make sure they meet their needs, but they don't require the faculty to do all the legwork? Right? That's an important decision that the institution has to decide to do. You can't just say, oh, that's a problem for the faculty, let the faculty deal with it, because that is a waste of their time and it's not good. Of course, we're grateful to people like Alex who are the pioneering, but then we don't want everybody to have to repeat that over and over again, right?
Alex, I also don't want it to go without being said that was a very successful tug on the heartstrings.
A what?
That's
very successful tug on the heartstrings. You melted my security control heart right away.
I see you're not a lawyer. I love lawyers, by the way. No, that's what we're doing. I try. We're doing stuff that's really meaningful to people. We're not just researchers using HPC. A lot of times, where people don't know what the hell we're doing, but we're trying to get a sick kid out of bed, right? And like supporting people doing that stuff. That's the mission. The scientific discovery and student learning is a mission in my world. Nothing else. Everything else is like way down the list. Except for football. Football's up there too. Sorry.
All right, folks. Erik, Alex, thank you so much for presenting. Thanks to folks attending. I hope this was really useful for you. If you have questions, you can put them in the call doc that's in chat. You can also send them to the EC mailing list. Happy to have conversations on that list. Don't feel afraid to reach out. People are happy to take a second out of their day to offer their opinions a lot of the time. So the other thing, if you would like to see other topics, please feel free to mail the list, mail Patrick and I. however you want to get it to us. If there's things that you'd like to see and think would be beneficial to learn about, definitely share them with us, and we can get those if it's a presentation or if it's a discussion item. We want to kind of have both and be able to have open floor for talks that are both sort of one to many, but also many to many. So I think it would be really useful. All right.
Thank you.
Thanks very much, everyone.
Well,
Take
thank
care.
you, everybody.
Thank you.
Thank you.